Today's topic is the increasing value of MLOps, or machine learning operations. It's a very exciting topic, and it's a very relevant topic in today's artificial intelligence and machine learning area. So I'm sure you guys are looking forward to listening more about it and learning more about what goes around when you try to operationalize machine learning lifecycle. Here's a little bit about me. I work as a chief architect for UST Global, which is a company which does professional services, products, and also build different kind of AI machine learning platforms. I'm also a visiting scholar at Stanford University, where I work as a visiting scholar, engage with the industry and academia, bring these products together. And I'm author of a few books, including Cognitive Computing Recipes and the bestseller in Functional Programming Languages. I collaborate with Microsoft as a Microsoft Regional Director and a most valuable professional in artificial intelligence. As a MVP for artificial intelligence, I get early access to the tools and technologies and the roadmap which Microsoft has around a variety of different tools and technologies surrounding cognitive services and machine learning. So I'm also a co-author of Microsoft's practice development, AI practice book, which is essentially an AI manual for enterprises who wants to get started with machine learning. So it's a fairly interesting area where a lot of enterprises are trying to get into the whole idea of how they can operationalize their tools. How many of you have actually encountered this scenario in the past? As a machine learning developer, as a data scientist, how many of you have seen that it took you 3 weeks to develop a model, but it takes more than 11 months to get it deployed? That's a typical scenario. It happens a lot in enterprises when we are trying to build a machine learning system. And eventually what happens is once you have built a model in your own Jupyter notebook and you're trying to operationalize it, when you're trying to deploy it, it takes forever. It takes a very long time to actually get that out of the door. Right? This is a tweet which is mentioned a lot, and this is not far from truth. You can see that happening a lot in industry, and I'm sure where you are working, you probably also encounter the same scenario as well. So there's a reason for that, and the reason is that your machine learning code is actually just one small part of this end-to-end pipeline. So you have ML code, as you can see on the screen, is a small component of this entire configuration, collection, verification, deployment, monitoring, this whole life cycle. This is just a small component of that, right? So when we talk about machine learning operations, what we are essentially saying is machine learning operations is the DevOps for machine learning, right? It is a discipline of building, training, and deploying your machine learning models either on premises or in the cloud or in a hybrid environment. So that whole end-to-end life cycle of taking the model from inception all the way to the deployment and operationalizing it and monitoring it, that is what a machine learning operations life cycle looks like. We have gone through that as an industry when we did the DevOps part of the thing. So you can think of, again, as DevOps for machine learning, but it is quite different from AI Ops. So AI Ops is a different discipline, which is applying artificial intelligence on operations. So they're very distinct things. The MLOps is essentially the DevOps for machine learning, how you can use this entire end-to-end life cycle and apply that, right? So this is, you can think of it as a formal definition of machine learning operations. I have a lot of stories from trenches, actually building and deploying machine learning models and operationalizing it, because it's fairly easy to build a hello world example of logistic regression or build a simple predictive analytics or time series algorithm and then showing it as a demo. That's fairly easy to do. But when it comes to doing the entire end-to-end life cycle, when you have to actually acquire data and the data is changing and you have to build that pipeline, then you have to make sure that your business matrices are there. Your modeling is actually, all the features are addressed, which are part of your business process. And also then you develop the model and you test it and you apply the whole continuous integration and continuous deployment, the CI/CD lifecycle of your model build and deployment. and then you operate it, which means you have to make sure that you have a feedback loop. Any kind of machine learning model which you deploy typically has a feedback loop based on how the data is changing and how the customer is reacting to that model. So that feedback loop and a continuous delivery actually makes it back to your model. How do you maintain that? It sounds fairly simple in theory, but when you start working with that real world data sets and real world deployment and monitoring of it, and on top of that, if you are doing like A/B multivariate targeting, or if you are doing experimentation of any kind, then it just becomes much more complex. So that is why it's really important to understand that machine learning operations, their platforms and tools, and I'll talk about it briefly, about what different strategies are out there to do experimentation and development and operation. But if you can take one thing out of this discussion, is that machine learning doesn't end, or your data science and data analytics exercises doesn't end at your Jupyter notebook. It doesn't end at your first Python implementation you have done, which gives you good accuracy, good precision, good recall, good F1 score. Right? That's the start of your experiment. When you get a good accuracy and precision and recall and F1 score and AUC, that just shows that your model has worked really well on the given data set you have been working on. However, it does not say anything about how would it perform in production if the data changes. If there's a data drift, if there's a model drift, how would it change? Also, are you accounting and measuring for those drifts? Right? So those drifts are important as the model changes in production. How would you accommodate for that? And how would you monitor that? So monitoring becomes a very a key component for that. I'll give you an example of a telecom provider which I worked very closely with, and they used MLOps capabilities in a public cloud to create an AI service, which reduced their wastage of the inventory for about with using daily forecasts for how they will sell different type of telephone sets, and when do you want to restock those with different kind of whatever is being sold most, they want to restock that based on it. So there was a team of data scientists they had, and they created data sets and different models which helped them to build that pipeline. But in order to operationalize it, they were struggling with it. So my team and I went in there, we built that whole MLOps pipeline for them that helped them containerize their implementation and run those AI jobs, and they were able to bring those containers back and forth and reestablish that. And that pipeline worked really well. We use Azure for that, Azure MLOps. But long story short, if you try to implement a solution which looks like just something which we'll do in business, where you would have for example, supply chain strategy needs to become a data science implementation, that requires an end-to-end lifecycle, and that's quite critical for you to do. Now, moving forward, this is from Azure. What are the best practices to optimize your machine learning operations lifecycle on Azure or virtually on any platform? This is specifically not to any specific cloud provider, but rather it is a very general idea that how MLOps lifecycle will apply. So you can create models with reusable pipeline using creation of retraining of model using MLOps pipeline in Azure, or you can use open source tools, which I'll show you in a second, what different open source tools you can use. You can register your model, so you need a model registry if you're building an efficient machine learning operations pipeline. You also need the scoring files and associated dependencies to be coupled. So when you're deploying it, you are not running into this whole idea of, oh, do I have all my dependencies? Do I have all my scoring files in there? These are some of the challenges of MLOps. Then you have to make sure that the models are registered and self-contained so they can execute on demand. And then, of course, the usability of the model is critical when you have to be able to utilize and publish a service. But you want to make an audit trail available for those models, which means if you are publishing a model, are you able to see what went into production and trace it back to the actual data source? So I'll give you a concrete example. We work with a lot of large banks and credit bureaus. And credit bureaus can accept or deny somebody's credit. So they can say, oh, this person is not going to get credit because of X. So bank will take that decision and then apply on that. So if this person's credit score is low, or if this person has too many accounts open, or if this person has no means to actually pay back that loan, they would get denied. But that person can come back and then say, hey, why did you deny me? Can you prove and tell me that's the reason? So they should have a way of actually recreating that experiment to be able to say it's not because of your gender or your ethnic status or your race or some protected attribute that we denied you. We denied you because of some material thing which actually has an impact on the repayment of the loan. So that kind of governance and auditability is very important for this machine learning lifecycle, especially due to the ethics of AI. So that's what a machine learning operations lifecycle allows you to do. Last but not least, you have to be able to observe the data drift. So if there's a model feedback coming in play, then you have to be able to see that to tune the model. This is a good overview of what a machine learning operations lifecycle looks like. So you analyze the problem, you fetch the data, you explore the data, you select the model, you train the model, you deploy the model, and then you make sure that it actually is accounting for feedback loop. Now, if you look at this, each component can be a whole masterclass of its own, but this is a fairly involved exercise of MLOps. Versioning of an experiment is really important, so you can always go back and then see what happened. So think of it as source control for your machine learning experiments, and MLOps provides you to have that. But how do you go about doing it, though? Right? So that's a question which comes up. It's like, this is great. I need MLOps. Now I realize that I can't just say that it works on my computer. That's a good enough answer. It's not. So how do I go about actually implementing that? And there are different ways of doing it. One is that you can use this stack, for example, Kubeflow with Azure Machine Learning, or you can store with GitHub. There's GitLab, there's Bitbucket. And then you can use your typical CI/CD platforms for Jenkins or DevOps or Circle CI, Bamboo, etc. All right. This is another recommended stack you will see over here, where you have Helm, GitOps, and then you can create Docker containers, and Argo is an open source tool. Kubeflow is one of the main tools used for MLOps lifecycle. With Pachyderm, you can also integrate with Kubeflow and then have the end-to-end lifecycle built using that. Or you can use a cloud service provider like Azure or AWS or GCP to have that entire MLOps pipeline. UST Global has built a platform which does something similar to that. But of course, if you want to build your own open source tool or use a cloud service provider, that's fine too. It's just that you need, as a developer, as a data scientist, as a machine learning engineer, that pipeline built, which actually monitors your machine learning lifecycle. It actually monitors your machine learning experiments, and it has reproducibility, right? So the challenges of machine learning operations include training your data sets, training your models, the reproducibility with advanced tracking of your data set, your code, your experiment, and the environment in a rich model registry, right? That's, I guess, in a nutshell, what the problem you're trying to address. You want to have an auto-scalable, powerful managed components where it can track your end-to-end lifecycle. And that is the promise of MLOps. That's what MLOps is trying to do. So if you do that, then you can create these efficient experiments and workflows where you can schedule and manage and build and deploy these CI/CD pipelines for your experiments, right? So model governance, model drift monitoring, as well as the data drift monitoring are the key components of this MLOps lifecycle. So I know I only have 20 minutes, so I'm running out of time now. So in this case, I think I've given you an overview of what MLOps is, why it is important, and as an engineer, what are the things you need to do to be able to accomplish it. So if you look here, it's a quick overview of how an Azure pipeline looks like. So you can see in Azure pipeline, it's very similar to, for the people who have seen DevOps pipeline, Azure DevOps pipeline. You can have releases, you can have build and training. That's how it looks like. But it actually connects with your experiment. So if you have seen the Azure UI, it connects with the experiment, and you can see how it gets deployed end to end. Again, not endorsing Azure or any other product, but rather I think you should focus on, as a machine learning engineer, what are the best practices, how you can optimize your machine learning lifecycle on Azure or on any other platform, and also do this entire end-to-end exercise for machine learning operations, because you can see that ML code, which most people focus on, is just a small part of this whole equation. And the rest of the things are really important for you to build a meaningful life cycle. I'll provide these slides as a part of this discussion towards the end. And if you have any questions, please let me know. And you can reach me at these addresses.